And hello guys, welcome back to C++ programming from noobs to programmers. I'm Satsuma Benji, and here we are again. I'm sorry it's been such a long time, been quite busy with college and then Christmas and other stuff like that. So anyway, let's get cracking. Today's lesson is on references. Last lesson I believe I covered arrays. It's been quite a while, I can't quite remember. And also I've lost my big sheet of lesson orders. It was saved onto my iPod. My iPod broke. Oh shit. Anyway, references. In C++, a reference is like it is quite literally a reference to another object. There's not a very easy way to say it, I suppose, but if I have this here, int var1, an int reference, a reference to an integer called ref equals var, then anything that I do to reference the ref, like if I add another 5, then what's actually happening is that this is adding 5 to the variable var. A reference is like adding another name to a variable. So I can call it var1 or var2, and anything I do to either, it'll affect both. However, only one space of memory is taken up, which is var1, being the 4 byte integer. var2, being a reference, takes up no memory at all, because when your compiler runs the program, it really takes this and pretty much just replaces it for that. Okay, so that's the basics of references, how to set them up. You put your type name, then the ampersand symbol, and your reference name. Unlike any other variable, references must be initialized first. You cannot initialize a reference after. The reference type must match the type that it is referencing. As I said, you must set it up. That there is illegal. We see here. I do like putting my syntax immediately after the type. So if I want a reference, I'll put the ampersand after the type. If I want a pointer, I'll do it like that. If I want a pointer of a pointer, I'll do it like that. I've not covered pointers yet, but I'll get onto those. But it is typically standard that a lot of people put them in front of the name, and there's a reason for this. Is that the fact if I want to create a couple of variables, I can do this by hitting the comma rather than writing them underneath each other. So if I create an integer reference like that and call it ref1, I put a comma, it's quite easy to be misled and think, name another one like that. I'm going to do this with pointers so I don't get the little errors. It don't really matter at the moment. I've not come across pointers yet. I mean, you've not come across pointers yet, I've not taught it. But that's in the next lesson. So this little star symbol here means declare pointer. But I'm just using this as an example because if I declare this to be a pointer like that and I want to declare another variable to be a pointer, it's quite easy using this notation that to get confused and think this is creating a pointer. What's actually happening is that my first variable will be a pointer and the second one will be a standard integer. So lots of people prefer to put the symbol right in front of the variable instead, so that way it's not quite as misleading. So here I've declared a pointer called ref1, a pointer called ref2, and an integer called ref3. So it's a little note on notation, that's syntax. Now, what can we do with references besides assigning a second name to a variable? Well, when I have a function, oops, why am I writing function? When I have a function that takes a variable like this, and if I typed var plus plus, meaning add 1, then if hang on, I've got to declare the function up here. I'm not sure if I've done declarations. If I'm not, I'm sorry about that. Just to make sure I have any functions using that appear after the namespace or inside the main, or inside another function previous, must be declared so your compiler knows what it's talking about. Declare function by putting its type, its name, and its argument types. You don't have to have a name of that there, but if you do have a name, you can also declare it to be a default, like that, which means I can call this function by going add 1, and it sends an integer with the default value of 0, or I can send add 1 and enter an actual value. Now, back to this. If I take a variable, so int var equals 5, and I try send that to the function add 1 var, like that, then what's going to happen is that this variable here, when it's sent to the function, it is copied, and a temporary variable is created. This temporary variable is sent to the function add 1, then 1 is added to that temporary value, and then when the function closes, the temporary values are deleted. So that's no good. If I want to do this to a number outside the function, then I can tell the function to accept a reference. Now, I don't actually need to declare a variable reference to do this. What happens is when I send my var, because the function is asking for a reference of a variable, then a reference of the variable is created rather than a copy of the variable. So now we have a reference. This reference gets added 1 to, and because a reference is just another name for the actual variable outside the function, this means that the actual variable now becomes 6 instead of 5. And then the reference is deleted here, but we still have our actual variable outside the function scope. So passing variables to a function by reference allows them to be edited by the function. However, passing just like that, no variables outside can be edited unless they're in the global namespace up here. Like that. God damn it. Like that. Okay, so that's references for now. I think that's all I want to cover in today's quick lesson, but they will be more covered about references. We're going to pointers, because pointers are quite a big deal to do with C++. Probably the main tool in any programmer's kind of handbook. So yeah, that's today's lesson, and I'll see you next time for pointers, and good luck programming.